Hey guys, we're back with the notes for 1.4. We're going to be on page 30 right now, working on solving and graphing our inequalities. So what I'm going to do is ask you to pause the screen a couple times, copy what you see, and then we'll get started. So go ahead and pause, write everything, and when you're ready, press play. Perfect. So at this point, you have already written all of this information. Let's go ahead and talk through these. Okay, first of all, I want to compare the symbols equal, greater than, and greater than or equal to. Whenever you have an equal sign, you are noting that the x or the variable can only be one exact number. Can't be 4.1, can't be 3.9, it's exactly 4 and only 4. If you're saying x is greater than 4, you're saying it can be bigger, but it cannot be actually 4. So we could use 5, 6, 7. We could do 4.1, anything like that, but we cannot include 4. That's why it's an open circle. It's not included. Okay, so one more time, I'm going to ask you guys to write this over here. Whenever you do not fill it in, we call that an open circle. So I'm going to write open over there. If you use an or equal to, it's kind of like putting those two ideas together. I could be greater than 4 or I could be equal to it. So we're going to go ahead and do that same arrow to the right, but this time we're going to fill it in because it includes 4. Whenever you have a circle that is filled in, we call it a closed circle. That's whenever you have the or equal to underneath your inequality symbol. Okay? Next thing I want to talk about is the steps to solving. So we've learned to solve like normal. We're solving for x, we're getting it by itself. But the only thing that's super going to change, I'm going to ask you to put a big star next to step 2. On step 2, if you multiply or divide by a negative, you must flip the sign. I'm going to zoom in. By flip the sign, I mean if you have a less than, you are going to change it to a greater than. If you had a greater than or equal, you're going to change it to a less than or equal to. You're just going to flip it over. Keep the line or keep it without a line, whatever you have. Okay? All right. I want to make sure that we see this word right here. We want to know if you are multiplying or dividing by a negative. That means what you're doing to both sides is negative. Doesn't mean there's a negative there. It means what you are doing to both sides is multiplying or dividing with a negative. Okay? All right, step 3 and 4 are all about drawing your graph. So on step 3, you're going to decide whether it's an open or closed circle, and you're going to draw it around the number. Step 4 is finally drawing the arrow to match your inequality. So whenever you are going bigger than the number, we are going to be moving to the right. If you are trying to be smaller than a number, you will be going to the left. It is always safe to think about a number line like 1, 2, 3. And left is like -1, -2, -3. Sometimes it's helpful to put that on the top of your paper so that you don't get the positives and negatives confused with your order. All right, I'm going to pause for just a second. Make sure you have everything that's blue that I added to the top. Perfect. All right, remember you can press pause anytime you need to, but we are moving down into the land of examples. All right, we're going to start with number 1. Will you pause the screen, copy this down, and then we'll talk. Perfect. So if we're looking at problem 1, we are going to cancel out that 5. He's on the same side with x, but he's the loner. I'm going to cancel out a -5 by adding 5 to both sides. That should eliminate my 5s. 11 plus 5 gives me 16. I'm not flipping. I added something on both sides, and I do not change the sign for adding. So my next line says -4x is less than 16. At this point, I need to cancel off the -4. I'm going to divide it on both sides. Right there where I highlighted in yellow, we are flipping the sign because we divided both sides by a negative. That's the flip. So notice I didn't erase it on the top part of the problem. I am only going to be changing it right there. Okay, so I changed my answer. I changed my inequality to the other way. It says x is now greater than a -4. I got that -4 by doing 16 divided by 4. So I've done the first 2 steps. I wrote in the box what that symbol means. If I was to read that out loud, it would say x is greater than 4. Ooh, sorry, that's a -4. That's my bad. Make sure -4. So I wrote -4 on my number line. I drew a circle around it. It is an open circle because there is no equal to underneath my symbol. It is going to the right because I want to be greater than that -4. Okay, so whenever I'm trying to be bigger, we're going to the right. If you have questions, you could go ahead and pause right here. Let me know. Otherwise, you're good to go ahead and keep rolling. Problem number 2, same idea. We are going to try to get that x by itself. So we're going to cancel out the loner 3. That's this guy. I'm going to subtract 3. What I do to one side, I do to the other. My 3's are going to cancel each other out. I now have 3x and a negative 18. If you're not sure, type that in a calculator. Because I subtracted, I'm going to keep my sign the same that I had. My next step, 3x is less than negative 18. I need to cancel the 3. I'm going to divide by 3 on both sides. The 3's are going to cancel. Now, I divided, but I didn't divide by a negative. I divided by a positive 3. So there's not going to be a flip on this problem. I'm going to leave it. X is less than, and the division gives me negative 6. All right, so I'm going to write this in a box. Again, we're saying x is less than a negative 6. So I put negative 6 on my number line. I draw my circle. It's open because it's not an or equal to problem. And because I want to be less than, I want to be smaller. I want to be going towards the smaller numbers. Okay, so over here, this is like negative 7, negative 8. Okay. All right, let's look at number 3. Number 3, we are trying to get x by itself. I really want you guys to stop the habit of rewriting the equation. So a lot of you guys have this weird habit where you like to put the x on the other side like this. We need to break that habit. So I don't want to see any of that on the practice or on the quizzes coming up, okay? All right, if I want x by itself, I need to cancel off the loner. That's the 13. 13 is positive, so that means we must subtract it. Do not let this subtraction sign confuse you. 13 is positive. I'm going to subtract 13 from both sides, bringing down my negative x because this cancels. 25 minus 13 is going to give me 12. And I subtracted, so I do not need to change my sign. However, I am not done. This x is not alone. This x has a little ninja one in front of it because it's a negative x. So here's what we're going to do. We're going to divide out that negative. And when I do that, I divided by a negative. So what does that tell me I have to do with my symbol? Hopefully you remember you're going to have to flip. So we're going to go ahead and write negative 12. That's my answer number. We're going to keep it an x because the negative one's canceled. But I'm going to flip my sign to be a less than or equal to. All right, if I write this out in words, this is saying that negative 12 is less or equal to x. But we want to know about the x, right? So if negative 12 is smaller than x, that must mean that the x is bigger than 12, or negative 12, sorry. So I'm going to put my negative 12 on here. It is a closed circle this time because it has the or equal to on it. And I want my x to be bigger than the 12 because the 12 is less than the x. I'm still going to the right. If it helps you to kind of think about who the alligator's eating, I know that's kind of how they explain it in middle school. The alligator eats the bigger number, right? So if the alligator eats the x is bigger. So this arrow tells me where my x is going. Okay. All right, we got one more on this page. Let's go ahead and look at number 4. Number 4, we're trying to cancel out the loner first. My loner is that 1. The opposite of plus 1 is a minus 1. So we're going to subtract 1 on both sides. My 1's are going to cancel. 12 minus 1 is 11. Since I subtracted, I get to keep all of the pieces on my sign. Okay? All right, now we're solving for x, right? So right now it says x over negative 3. Over means that we are over means that we're dividing. So to cancel that, we need to multiply. Okay? So if I want to cancel out that negative 3, I need to multiply both sides by a negative 3. My negative 3's are going to cancel, and right here, because what I did on both sides was multiply by a negative, that's going to tell me that I want to flip it. Okay? All right, my 3's cancel. I have negative 3, 33. Flip the sign over is less than or equal to the x. Let's go ahead and write that in words. So negative 33 is less or equal to x. I'm going to put negative 33 as my number. It is a closed circle because it has the or equal to line underneath it right here. And because the alligator is eating the x, or because the x needs to be bigger than the negative 33, I want my x to be moving towards the right. Okay. All right, I would encourage that you pause the screen right here, copy anything you missed, or listen to it again if you're still not convinced or you're a little bit confused. When you're ready, flip to the back page. Perfect. All right, on the back page, we're going to start getting a little bit more complicated than just the two-step problems. So let's go ahead and look at problem 5. Problem 5. We are first of all going to notice that there are variables on both sides. Nothing to distribute or combine, but we do need to get all the x's to one side. I would like you to make a note. It will make your life a lot easier if you put all x's on the left. I would say that if you can remember when to flip, moving all the x's to the left guarantees that you don't have to rearrange or rethink any of your order, okay? All right, so if I was working on number 5, I would say all my x's are going to move left. I'm going to go ahead and get rid of the negative 7x, and I'm going to move him to the left-hand side. I canceled him out by doing the opposite. The opposite of a negative 7x is to add 7x. So now these are gone. 2 plus 7 gives us 9x minus 5 greater than or equal to 4. Canceling off my loner, so the opposite of a minus 5 is a plus 5. When I do that, my 5's cancel, and I get 9x is greater than or equal to 9. Now, I haven't multiplied or divided anything yet, so there's still no flipping. Right here, my last step is to divide by 9. I ran out of space, that's okay. I'm going to put my answer over here. If I cancel out these 9's, I didn't use any negatives, so x is still greater than or equal to 1. My answer is 1. I put it on my number line. Closed circle, because it has an or equal to, and if I read this, it says x is greater than or equal to 1. So I want to be greater than. I want my x's to be bigger than that 1. Okay, so I'm moving like towards 2 and 3. Let's go ahead and hit number 5. Problem 5, I'm thinking moving all the x's left, that way I don't have to rethink about my directions, okay? All right, if I want to move an 8x, I'm going to subtract 8x from both sides because my 8x was positive. 3 minus 8 gives me negative 5x. I still have not done any multiply or divide. I'm going to cancel off that minus 3, he's the loner, by adding 3 to both sides. When the 3's cancel, it leaves me with a positive 15. And we should have one more step. I need to get rid of that negative 5. Remember, when a number is stuck to a letter, that's multiplication. So we're going to divide by a negative 5. And right there, I'm going to highlight it in yellow. I divided by a negative. So I'm going to make a quick note to myself right here is where I flipped. When the 5's cancel out, you get the answer. X is, flip that sign, less than a negative 3. Negative 3 is my answer. That's what goes on my number line. It's an open circle because it does not have the line underneath it. It's just a regular less than. And if I read that, x is less than negative 3, that means I want to be smaller than a negative 3 for my x's. That means I'm going towards the negative 4 and the negative 5's. Okay. All right, when it gets to problem 7, 8, 9, and 10, I want you guys to make a quick little note. We're going to kind of write sideways down our paper. I want you to write that these are compound. These are called compound inequalities. Compound inequalities means you have more than one inequality symbol, okay? More than one inequality symbol should mean that you have more than one circle or more than one arrow, okay? They might overlap, they might cancel each other out. We'll see that in just a second, okay? I'm gonna do these large and one at a time. Let's talk about number 7 first. All right, whenever you see a word in the middle, that means this is two separate problems. We're going to solve these equations completely separately. Both of these are really short. 2x is greater than 4. All I have to do is divide the 2. No flipping. There's my first piece. Okay. Second problem is still a one-step. X minus 3 less than or equal to negative 4. I'm going to add 3 to cancel it out. Negative 4 plus 3 gives me a negative 1. I did not flip anything. That's my second piece. All right, so let's think about this on a number line. If you think about 0 in the middle, I got 1 and 2, so one of my numbers is a 2, right? It's an open circle because there's no line underneath this guy at the 2. I also have a negative 1 as one of my answers. He's going to get a closed circle. He's getting a closed circle because he does have the line underneath, okay? All right, so I got my circle situated. Now let's think about this. This says I need my x to be greater than the 2, so that's going this way, or less than the negative 1, so that's going this way. Or means it could be both. Or I'm going to use the word either. Could be either. So if I say you could have 100 in algebra, or you could have less than a 70 in algebra, both of those are options. Okay, I can include both of those arrows. Okay, I'm allowing either one to be okay. This or word is what allows both of this to take place. The word and requires both requirements to be true. We will see that eventually, but and gets a little tricky. Or it just means graph it all. Okay. All right, let's do number 8. Number 8, we see the word or, which means we have two problems. I'm going to go ahead and divide it by a negative 3. I have a negative. I'm dividing it out on both sides, which means we're going to flip it. X is less than or equal to a positive 7. Let's look at the other side. I want to get the x by itself, so we're going to divide out that 2. No flipping on this problem, so x is greater than 3. All right, so I need from 3 to 7. Let's do 2, 3, 4, 5, 6, 7, and 8. I'm going to put a circle around the 7 that is closed because this guy has an or equal to. I'm going to go ahead and put an open circle around 3 because he does not have an equal to. And when I look at this, my 7, I need to be less than 7. For my 3, I need to be greater than 3. So this problem says which numbers could be less than a 7 or greater than a 3. When I look at this, I'm allowed to use all of these. 2 would work. He would be an either or. He's less than 7. Yes. 5 would work. He's less than a 7. He's good. 7 would work because it's or equal to. 8 would work because it's still greater than a 3. Since all of these work and all of my arrows are overlapping, this is a problem where we would say all real numbers. Okay? What is x allowed to be? Where would you shade there? All of the possible answers would work. So what most teachers will tell you to do is get rid of all of the circles, and you would kind of just acknowledge that you get to do this. Okay? All numbers that are greater than 3, all numbers that are less than 7, that's everything. Okay? All right. If you need to pause it and copy anything for 7 and 8, we got 2 more. We're almost done. All right, let's talk about number 9. Number 9, this is compound inequality because they are 2 symbols in the same problem. All right, we're going to kind of think about these like those dotted lines when we were doing our equal signs. Instead of saying what you do to one side, you have to do to the other. Now I say you have to do it to all 3 sections. All right, so look at where our x is. Our x is in this middle piece, right? So when I say who is in the section with x that looks like a loner, that would be our 1. We're going to eliminate him to start with, just like we would normally. I'm going to subtract 1. But what you do to one section, you have to do to all sections. So I'm going to go ahead and subtract 1 from all of the sections. My 1's eliminate. That leaves me with 4x. I subtracted, so none of my symbols are changing. 9 minus 1 gives me an 8. Negative 3 minus 1 gives me a negative 4. Okay, remember, you can slow this down or pause it anytime you need more time to think or write. I'm still trying to get the x alone, so who's in here with x? That's the 4. I need to divide that 4. What I do to one section, I have to do to all of my sections. My 4's eliminate. I divided by a positive, so I am not changing my symbols. 8 divided by 4 is 2. Negative 4 divided by 4 is a negative 1. So if I read this, I'm going to write it in words. I'm saying x is between negative 1 and 2. So if I was going to be graphing this, I only need to have numbers from -1 to 2. I'm going to not include 1, it's open circle, no equal. Not include 2, it's open circle, not equal. And I am only including the x's that fall in between them. Okay, that's what that graph would look like. If this was written out another way, like another kind of problem, it would say x is less than 2 and x is greater than -1. So this is one of those and requirements. You have to meet both. That's why I'm not including anything over here, and I'm also not including anything over here. And means you have to meet both requirements. Okay? All right, we got one more problem. Let's look at number 10. We are trying to get that x by itself. X is in the middle, so I'm going to eliminate the single. That's the 4 plus 4. What I do to one side, I do to all my sides because we got little dash lines in here. Okay, 4's eliminate. I keep my -5x. I am adding, so I'm not changing my symbols. -29 plus 4 is a -25. 11 plus 4 is a 15. We're still trying to solve for x, so that means I need to get rid of the -5. I'm going to divide him out, but right here, because I'm dividing by a negative, and I didn't do a good job with the colors, because I'm dividing by a negative on all of these, I'm flipping the signs. Okay, I cancel the 5's out, so I have my x. 15 divided by -5 is a -3. -25 divided by -5 is a +5. Now, because this looks weird, we do not usually want the bigger number on the left. So I'm going to make a note that you need to rewrite this from least to greatest. Okay, so think about I'm going to take the whole thing and flip it over. So -3, flip it over, and the 5 is on the end. Because that -3 alligators went the whole other direction. It's like I spun the whole thing over a mirror. Okay? All right, so if I am going here, let's go 0 in the middle, -1, -2, -3. 1, 2, 3, 4, 5. I want an open circle on the 5, open circle on the -3. Neither of those have an or equal to, and I'm shading in the middle. Okay? I'm going to zoom out. If you missed anything on 9 and 10, go ahead and copy it now. Otherwise, you are all set for your 1.4 notes. Have a great day.